class. How's everybody doing? Good? Doing good, thank you. All right, so most of us are here, that's good. Interesting layout. I wonder what's in store for us next time. Maybe it's going to be outside, who knows? Hopefully there's still desks in this class next time. I mean, stay tuned. I mean, the suspense is killing me. Can't wait. Something to look forward to next week, right? Like, I wonder what's going to be the layout. So thank you for showing up. Now we're going to cover the next topics on lecture. We're going to go over the charts and these types of tabular forms of presenting data, and then we'll review Article 1.3. You can take volunteers to answer some of these questions as well. And then I'll give you assignment number 1 preview. Yeah, that's gonna be fun. Who's familiar with Microsoft Excel? All right, 1, 2. I mean, at least you know the name. All right, majority of you. Right.
On a scale of 1 to 5?
On a scale of 1 to 5. That's now answer this. Is that an interval or ordinal variable?
Interval, assuming there's a space.
Yes. All right. Were you all coming from the same bus? Or yeah. It's a joke. It's a joke. Thank you for showing up. Let's see. So I'm asking the question, how familiar are you with the MS Excel? Let's say on this case, on a scale 1 to 5, 5 being highest, using an interval, equal spacing, variable scale. All right, so those with 5, raise your hands. All right, 4s, 3s, 2, okay, not bad, 1, all right, 0, okay, -1, okay, all right, good to know. Well, this is an opportunity to learn more about Excel. Excel has this statistics course is much more than just the content. It's also understanding how to use the tools necessary to generate statistics. So that includes software programs. And in this course, you learn, the intent is for you to learn how to use the Microsoft Excel, because by far that is the most popular program out there. It's part of the Microsoft Office suite, which includes Word, PowerPoint. If you know those programs, I guarantee you the computer, wherever you're going to be working at, the computer will have those installed. If not, those are like the common programs installed in most organizations. We'll also have opportunities to use SPSS, which will help you also if you're interested in doing advanced type of statistical analysis as well. So the good thing is that I walk you through the steps. I actually record it, and I don't give you the answer, but at least I give you a video how to get to the answer, which will help you complete the assignment. Is that fair enough? I see some people shaking their heads. No, I'm just kidding. Okay, so that's good. So I'll do that at least to help you kind of walk you through that assignment so you can complete it. Okay, so we'll cover this, and then we'll do the Article 1.3 review, and then we'll end it with the preview. Hopefully we have time. All right, let me start. Okay, so we left off last time on sometimes it can be misleading. We left off on line charts, so sometimes it can be misleading how data is presented. So here's an example of that. So you would have a line chart like that. You would think like, oh my gosh, pass rates have soared. Where if you see that the bottom scale of the years is just really compressed. But if you look at the next one following that, how expanded the years are, it doesn't look that as dramatic. So it's something to just keep an eye for when anytime you see charts in terms of the scale of it. looking at the patterns or looking at how things increase or decrease. It's always to just be mindful of things like that. The next topic is pie charts. This is a way to illustrate data. So just remember that statistics is really meant to be communicated. It's meant to be expressed. And there's easy ways, or at least better ways, to communicate statistics. Now, a lot of people don't like to see pages and pages of numbers. First of all, it's too time consuming to evaluate and analyze pages and pages of numbers. So statistics serves a purpose of summarizing data and actually using data visualization techniques like figures, charts, line charts, things like that. It actually makes it much more engaging and much more pleasant for you to review it and analyze. Particularly in any field that you're going to be in, if it's related to child care or child development, or criminology, or anything related. It could be even in any field. These are essential tools to understand and learn that data, it comes in all shapes and forms, can be collected for analyzing all sorts of things, and this is a way to communicate data in much more succinct, much more engaging manner. So here we go with pie charts. So pie charts so you got to know the tools of communication. You got to know what's the trade-offs for each one. So I already explained to you line charts. It's good when you have time and years, and when you have the progression of things have changed over time. Pie charts are good when when you're trying to compare parts of a whole. It should be used for 3 or 7 categories. They do not show changes over time. So that's a drawback of pie charts, that it doesn't illustrate how things have changed over time. So here's an example of that. Here we have California through 12 funds by source. So you have multiple categories of source of funds. It illustrates to you like where is the biggest source of funds for K through 12 funding. So based on this pie chart, can you tell me where does most of the funds come from? State funds, which is 60%. So you see, that's the benefits of illustrating data using a pie chart. You can easily identify the biggest chunk of the biggest source, just like that. So here's the ethnic diversity breakdown of faculty at Cal State LA here, this school. What can you tell me about this chart?
We have mostly white teachers.
Okay, we have mostly white teachers. Is that consistent from your experiences? No? Some yes, some no. Depends on the major. That could be it. All right. And do you think this is pretty diverse? I mean, depends on what you're measuring. Is it diverse enough?
Pretty diverse.
Okay. I'll take your assessment. Okay. So you see, that's the whole point of the pie chart. So you can make these type of determinations. And you could also compare it from previous years, how things have evolved. But you have to compare with other pie charts. You can't really see it based on just this pie chart by itself. All right, so this gives you a percentage of calories from added sugars or by food type. So based on this, from the general population, percentage of calories were, sources of calories. Based on this, where do most of the calories come from? Yes, soda, sports drinks, energy drinks. Is that consistent from your experiences or what you have known from other individuals? I guess it depends. All right. Let's see. What should your financial pie chart? So this gives you an optimal pie chart of like where to spend your money. So 28% should go to housing, 20% daily spending, and et cetera, et cetera. So these are just some examples of how to use pie charts. The next one is bar graphs. A bar graph is drawn using rectangular bars to show how large each value is. The bars can be horizontal or vertical. And it's a way to visually represent a set of data. Bar graphs are particularly useful for data that is easy to categorize. The category, or like nominal variables, is traditionally placed on the x-axis, and the values are put on the y-axis. Should be used for comparison between discrete categories. So this is an example of that. So in this case, we're using time, but we're using time in comparison to different years. And the x-axis is years. The y-axis is the number of student enrollment. California public K through 12 enrollment. So it gives you a breakdown of the ethnicity of student enrollment. So based on that, which one is the biggest ethnic enrollment? Yes. Has it been shrinking or increasing? Increasing? You see, that's just an example of how to analyze charts. You could look at how, always ask the question, has it changed? Is it the same? Has it, did it increase, decrease? Those are key questions anytime you analyze bar charts or any charts, like just to compare it with the previous years. All right, this one is percentage of students who met or surpassed standards. So that gives you California bar charts there. Math and English. Math is the orange. English is the blue. So it's California numbers versus LA Unified. Are there differences between LA Unified rates versus California rates?
Yes, but not by much.
Not very much. So in this class, we'll eventually talk about what is much. Let's say if it was by 1%, is that much? Is that high? I mean, it's really dependent on the person. Some may say, wait, well, 9% is not much of a difference. But I think based on this, if you think 9 is not much of a difference, or it is a difference, you can state that. But eventually, I'll give you tools that will help you determine what is much and what is little. But bar graphs allows you to make that type of analysis. All right, LA Sheriff Station crime rates in 2014. So here's another black bar graph. It's based on city. It's categorized by city. And then crime rates values are on the bottom x-axis. So based on this, which one has the most crime? Anybody lives in West Hollywood? No. Nobody wants to admit it? Okay. No, just kidding. I don't live in West Hollywood. Or else I would have said it'd take me 2 hours to get there. Obviously, it's less than that. Okay, so, Marina Del Rey. Anybody who lives in Marina Del Rey? Yeah. All right, so with bar graphs like this, you can make those comparisons. So I guess the good place to live is Crescenta Valley, wherever that is. Does anybody know that place? Crescenta Valley?
Probably why it's very low crime rate.
Nobody knows about it. Nobody goes there. I don't know who lives there. Good to know. Oh, this is a good one. Has anybody heard about this? So Cal State LA comes at the highest in terms of upward mobility. I don't know if you heard that. This is a big news. So what does it mean? It means that students that come, let's say, from the bottom 5% reach the top 5% after they graduate from Cal State LA. So they did an analysis, a big research study about this, and we came first in terms of students that come from, let's say, low socioeconomic status, and then after they graduate, they go to the top, or at least the top 5th. So that's promising. That's actually a good thing. So it compared Cal State LA with other universities. I think that's the second one is probably in like New York University. So you can do that with comparison to compare with other universities. All right, here's another one. Okay, so this is more like a table. So in this case, a teacher was providing or using various techniques to reward her students. So in this case, the teacher used verbal praising 21 times, stickers 6 times, and privileges 3 times. So a frequency count was tabulated. And then a percentage, so it was out of 30. So you had to add them all together. You get 30. So if you know these numbers, if you know this number and you know this number, you can create like a percentage. So 21 over 30, that's 70%. 6 over 30, 20%. 3 over 30, that's 10%. And then you can create a bar graph based on that as well. All right, the next one is tables. Tables is the data structure that organizes information into rows and columns. So the key benefit of that is that it should be used for small data sets for comparison. For example, number of discharges in a month by a consultant shows all data. It's much more precise and can be hard to interpret or see patterns. So here we go. Tables and frequency count, proportions, percentages, and distributions. So here's an example of a table. You can use percentages to illustrate, like, for example, how many males and females are in the class, or how many freshmen, junior, or seniors are in the class. You know, it gives you that data. If you want to get the whole point of tables, it gives you precise information. So if you want to know how many freshmen there are, it tells you there's 11. And then there's 84% of freshmen in the class. Not this one, but another class. Same thing with juniors and seniors. So this is an example. So scores from 50 students on the multiple choice exam. So let's assume we gave a multiple choice exam of 50 students, and we documented their scores. Does this make sense to you? Can you easily analyze the data scores based on this? If you were to be working and the supervisor says, please provide me a table of student scores, this is what you're going to produce. And why is that? Why not?
We have to do the math,
I'm sorry?
we have to do the math yourself.
Yes.
It's not in ordering, so probably you would want to put 50, 60, 70, 80, 90, 100, and then from lowest to highest.
Okay, good.
It doesn't feel process, you can't really process what that means.
Yes, exactly. Exactly, very good points. So that's where statistics comes in very handy, because data in its raw form like this, it's not very useful unless you're, I don't know, some kind of special genius that can easily digest this. But other than that, I'd say 99.9% of the people would not able to analyze this data. So what you do is one key thing to do is sort them out. You can sort it. So that's what happened here. You sort the data from highest to lowest. And instead of documenting each number based on how many times it shows up, you create a frequency column, which is that italicized F there. So you get the score, and then you see how many times that score appeared on the data or in the data set. So in this case, you just put 1, 98 one time, 97 none, 96 0, 95 0, et cetera, et cetera. So you sort them, and then you identify how many frequently or how many times did it show up in the data. And so the frequency comes in handy by using that column. I mean, you can get more sophisticated by creating what we call limits, ranges, where you say, oh, well, 95 through 99, 90 to 94, and then use a frequency count for that as well. The same total is for both. This one, the one on the left, uses a much more wider range versus the one on the right uses a much more narrow range of 3. So here's another example of that, where you use ranges and then just tally, which is the frequency. So 95 to 99, 2 people got those scores. 90 to 94, 4 people got those scores, and so on and so on. The next step you can do is add what we call a proportion column and a percentage. So a proportion, essentially what it is the total. So you get the frequency divided by the total, and that's the proportion. So 1 over 50 is 0.02, 2 over 50 is 0.04, and so on and so on. So it's just this number, whatever the frequency is, divided by the total, that gives you the proportion. If you want to convert it into percentage, just move the decimal number twice to the right. That's a percentage. Any questions so far? It's going to get exciting, trust me, okay? And then the purpose really about this is it provides with at least a way to compare both. Now, for example, if you had 2 different sections taking the same exam, here we have frequency and percentages of people taking, of achieving those scores. So you can have different, at least you can illustrate those different sections. Now, based on this table, which one do you think, which section did much better? Or at least relatively better?
Section 2.
Are you sure? By the way, I always ask, are you sure?
I was.
I know, I get that. I get that a lot. So every time I ask, are you sure, then it makes people think twice and 3 times, and they're like, maybe I'm not so sure. So, what do you think?
Yeah, section 2.
Section 2? Are you sure about that?
Yep.
All right, some confidence. Okay. I would say you're right. Section 2. It's okay. You could have said yes, but it's okay.
I was.
You're like, where am I coming from, right?
I was somewhat sure. After you
Okay.
questioned me.
It's okay. It's cool. So I would say section 2. Just looking at the sheer numbers of this, if you look at a lot more people scored 95 to 99 here. If you just compare these two, majority of them right here. So one can say section 2 did a lot better than section 1. So that's the benefit of having these columns that you can compare. So there's going to be more calculations. We have the cumulative frequency, and then the cumulative frequency percentage. Cumulative frequency is defined as the running total frequencies. Then the percentage is the same thing. It's just the cumulative frequency, but the percentage version of it. So cumulative percentage column divides the cumulative frequency by the total number of observations. So we have these values and frequencies. All right, so just remember cumulative frequency. The way to get this essentially is to start from the bottom, and then it says frequency is 1. All right, and then you go on to the next one. The next frequency, cumulative frequency, is you add this one to the next value here, and you get 2. And then you add that to the next frequency. 2 plus 2 is 4. 4 plus 4 is 8. 8 plus 6, 14, and so on and so on. That's how you would get cumulative frequency. You do that all the way to the top, and you get 50, which is the total number of students. Cumulative frequency, if you can get cumulative frequency, you can get cumulative percentage. This is essentially, all you need to do is divide that value by 50, and then just move the decimal number two places to the right, and you get the percentage. You divide that by 50, you get that. You divide it by 4 divided by 50, and so on. That's how you would get the cumulative percentage. Percentile rank, I'm just going to gloss over this one, but it's good to just understand just the concept of it. We're not going to really do calculations on this one, but it just reflects the percentage of cases falling below a given point. It's very similar to cumulative percentage. That's why I tend not to focus much on this one, but that's the formula to get that. So I would say in this class, we can just use cumulative frequency percentage because it gives you pretty much a close account to the percentile rank. Has anybody taken the SATs? All right, so when they give you a score, and then I think, it's been years since I took it, but on the same table, they should have like a percentile rank, like how many people scored below you. Do they still offer that? So share with us. No, I'm kidding. I'm just kidding. Share with us your no. So in my case, I got 2. No, okay. I'm not being funny today. It's okay. Tough crowd. It's going to take some time. Maybe it'll be better next week. My jokes will get better next week. All right, give it some time. So essentially, that value tells you how many people you scored better, in terms of percentage. So it's like, in that ACT score, if you got like 85, you scored better than 85% of all test takers. Percentile rank is it's the same thing. Cumulative frequency percentage, not exactly the same thing, but close enough. Who's heard of histograms? Anybody? All right, this is my favorite graph, by the way. All right. We're going to do a little exercise. Let me show you what a frequency or histogram is. So let's do this. All right, so the question is, how many pairs of shoes do you own? Now, if you don't want to reveal that type of personal information, you can make it up. It's fine, right? But the question is, how many pairs of shoes do you own? All right, we're just going to go from left. We're going to ask everybody in this class. All right, starting with Janelle. All right.
A lot.
You have to give me a number. You just make it up. Give me an approximate. Really? Wow.
Probably more.
It's okay. We're not here to criticize other people's number of shoes. Yes, you're.
25.
8.
Sorry.
15.
You're like thinking really hard.
The difference between the girls are
12. About 40. Excuse me.
I'm sorry?
40.
40? Is that all? I'm just kidding.
You have like one nice
20?
Educational guess.
That's fine. I'll take that. Wow, pretty popular. 20?
I want to say close to 70 as well.
70? Your turn.
I already said 10.
10?
Yeah, that was.
Oh, you said it?
Yeah.
Oh, okay. Sorry, I messed up. Okay. 40?
Yeah.
All right, I need your help. I need to sort this out. Okay, so what's the highest? Okay. What's the second high? Okay, 70's twice, right?
Yeah.
Okay, third highest.
40.
40.
Twice.
Twice?
Yes.
All right, where's that 40 there?
The bottom.
All right, next size?
20.
25.
25?
2 25s.
Two 25s? All right, hold on.
Did I say 8? Oh my god.
All right, next one.
3 20s.
All right, next one.
19.
19.
15.
12.
2 12.
Two 12s? All right.
11.
All right, where's
2 10s.
two 10s?
And 2 8s.
2 8.
Two 8s? Is that it?
Yeah.
All right. Then I'm going to draw a histogram. All right, so will I do it right? So this is a frequency. Now I'm going to use limits here. 0 to 10. 11 to 20, 21 to 30, 31 to 40, 41 to 50, 51, I ran out of space, 60, 61 to 70. All right. So how many fall 0 to 10? Count.
4.
4? Oh, okay, hold on. Give me this. 1, 2, 3, 4, 5, 6, 7. Okay, so 4, right?
Yeah.
All right, so there we go. How many fall from 11 to 20?
8.
8? Uh, 21 to 30?
2.
Hold on. Okay. 31 to 40?
2.
41 to 50?
7.
51 to 60? 61 to 70?
2.
All right, we got ourselves a histogram. So it's a visual illustration of a frequency count. Based on this, which is the most popular range of shoe ownership?
11 to 20.
11 and
So for those of you who are owners of 11 to 20 pairs of shoes, you're pretty much the most popular one, or the most frequent group. All right, so which one is the outlier, or like the most extreme?
2 70s.
Well, which range is the most extreme?
61 to 70.
So I would say this is a, well, kind of special group. So the bulk of shoe ownership pretty much lies in, I'll say, between here. So I'll say pretty much 0 to 40 is like the, let's just say almost 90% of the students own 0 to 40 pairs of shoes, and about, depending on how many people we have, a certain small percentage of students own 61 to 70. Wow, that's cool. I didn't answer, so come in next week and I'll give you the answer. How many pairs of shoes I own? Actually, no, I'll give you the answer, since we're all kind of like in a sharing mood here. I think I own like 8. So I think there might be some gender differences, but still. But even though I think we have both gender represented in the 61 to 70, so that's interesting. I'm sorry? Okay. So, all right, good to know. You see, now you know how many pairs of shoes we own. All right, don't use it against your fellow classmate. This is very, very personal information. All right. Anyway, that's a histogram. So let's see. personal questions to come later. I'm kidding. All right, so the purpose of histogram is chambers. Those bar graphs, or those bars that I drew, are chambers to graphically summarize the distribution of a univariate data. So in this case, univariate is just a single variable. Histogram graphically shows the center, the spread, the skewness, the outliers. It could be multiple modes. We'll talk about modes as well. So here's the histogram of the student scores. Do you think it's pretty symmetrical? I mean, that's one thing to evaluate histograms. Just remember the y-axis is frequency, and then the ranges on the bottom is the ranges of scores. Do you think this is pretty symmetrical? Is it skewed? What do you think?
Pretty symmetrical.
Things pretty. Sometimes it depends on the eye of the beholder, you know.
It's definitely skewed to the right.
It's like, okay, looks like skewed. I may get differences of opinion on this one. Sometimes in the most theoretical sense, yes, I would say it's skewed. Sometimes in the practical sense, you may say it's pretty normal enough or symmetrical enough. You may get different opinions on this one. But yeah, I think if you calculate it mathematically, I would say it's skewed. So depending on also on the ranges, these are the same distributions. So just be mindful that what type of ranges you use, because if you use like a wider range, it's going to look all spread out like that. But if you use a much more narrow range, it's going to look pretty compressed like this. So always be mindful of how data is illustrated using histograms in terms of the ranges. So you could use this also to kind of determine how much people or how much each score is recorded depending on the distribution. So this is just an example. You know, as we go along forward with this course, there's going to be opportunities where you can identify like these two key points of a histogram and how much of the area it represents, or how many percentage of students got those scores based on this. As we go along in this course as well, we're going to talk about central tendency, which is the average. So score distributions may vary by average as well, which is the center of the score distributions. It could also matter not only where they are, but also how if the peak is pretty narrow or is pretty spread out as well. So here we have examples of distributions. And you may come across distributions that could be what we call in this case bimodal, where it has two peaks like that. In this case, it's negatively skewed or skewed to the left. So one way to memorize this, when you see distributions that are skewed, that are not symmetrical, like identify where the tail is for a skewed distribution like this. The tail is on the left. Therefore, it's on the negative side, or you can say it's negative, or on the left side. So it's skewed to the left. When you look at this distribution, and you see that there's a longer tail on the right, this is what we call positively skewed. It's skewed to the right. And the other two, we rarely see those two, but those are called J-curves and reverse curve. But these are like the most important and most popular ones. So anytime we do like histograms, analyze it if it's symmetrical. If it's not symmetrical, is it skewed? Skewed in what direction? Is it negatively skewed, positively skewed? Ask yourself the question, where is the tail? Is the tail on the left? Therefore, it's negatively skewed. If the tail's on the right, it's positively skewed. All right, who wants me to grade on the curve? Raise your hand. Really? Are you serious? You want me to grade on the curve? Are you sure about that? Are you sure?
Depends on how well everybody is.
Yeah.
True? Okay. Apparently the police is after me. I gotta leave the class. Do assignments about 5 and 6. Apparently they're out. Menacing. All right, so look, we'll take a vote right now. If you want me to, okay, well, before you, I want you to
Well,
be,
it depends who's into math.
I want you to make an informed decision. An informed decision. If I were to grade you on the curve, that means certain people will get A's, certain people will get, certain number of students in this class will get B's, C plus, C minus, and D, okay? But if I don't, and I just I use my, like a rubric, where I use that everybody, if you scored like 90 and above, in the final score, everybody will get an A.
It depends on how many people are gonna get that A. If a lot of people do well, then it doesn't benefit for the curve. But if a lot of us do really bad, then
Yes.
the curve will benefit.
So ask yourself the question, is my course very rigorous that you may want to be graded on the curve? Am I that harsh?
We haven't had a test yet.
Okay. So
I feel like you're full of surprises.
I'm sorry?
I feel like you're full of surprises.
You
I
think
don't
so?
know what to
You think so?
expect on the test.
It's interesting. I get that feeling from most students in the beginning of the weeks, and then later on they realize, well, he's not that bad.
I didn't say you're bad.
No, I know. What I mean by is like people have that a bit of a concern that it's like for example, it's like we don't know what's in store. We don't know how the exams are. We don't know how rigid or how rigorous I am in grading. So I think you don't know enough about me to make what we call an informed decision. Is that accurate?
Yes. I'm solely judging on the fact that you like to teach statistics.
Oh, okay. So okay, based on that, what do you think? Do you want me to grade on the curve or just use the strict rubric of anybody who gets a certain final score of 80 to 85, 80 to 89 gets a B, 90 to 100 gets an A?
It depends who's majoring in math here.
No, actually, no, because option B doesn't really matter. Option B doesn't matter. Option B does not compare you with other students. It really just depended on how well you do. Where versus option A, which is this, it's dependent on where you are in relation to other students. So,
How well does everybody think they're gonna do?
so option A,
I have to do well in graduating.
option A is much more competitive. All right, option A is more competitive, where option B is more collaborative. All right, so
you
we
just go based on how we do, and then you can figure it out. And just see how the class did. If
okay,
there's
option A is going to rank you, how you do in relation with other
Yeah.
people. Option B is like if you just get 90, no matter if you're in the top 20, you still get an A. Let's say you're like the 20th person on the class, and everybody else scored above you. You still get an A.
Well, really, for option A, you don't really lose, right? Because if you get let's just say average on the test, you get like
A lot of
like
talking.
Let's decide after the first actual exam.
I'm sorry, go ahead.
and there's like 4
Wait, I gotta go. I'm sorry. I'm sorry, go ahead.
Let's just say that the highest grade was an 85. Well, then 85 would be like the
A.
equivalent of the A, right? So
Yeah, so it really depends on how rigorous this course is.
It's a regular
I
way.
mean, doesn't it
No
depend-
curve.
I'm sorry, regular or no curve?
No curve.
No curve. Okay, I gotta vote for no curve. Anybody else?
I gotta vote for curve.
You vote for a curve?
Yes.
Wow, all right.
You don't really lose with the curve, right?
Yes, you do, because if everybody gets
Can we get back to you
90%.
next week? We'll have a group discussion.
You know
We want to see who the really statistical students are.
By the way, I ultimately have overruling rights, just to let you know.
So it doesn't matter.
Well,
You should make that a test question.
I tell you this, based on historical accounts of me teaching this class in the past, a lot of people do well. as long that you come to class, you don't fall behind, most people do pretty well. So based on that knowledge, you don't have to decide right now. But, like I said, just follow along, do your assignments, try not to just keep up. Most people do. So I don't think I'm that rigorous. I mean, I do have high expectations, and I want you to learn definitely all the key concepts. But I don't make it to the point that it's sink or swim. I want to make sure you learn the material. And I give you opportunities to demonstrate that. All right, so let's just leave it like that, all right? Any questions, see me after class, I guess. Anyway, so that's the curve type of grading, where the top 2%, so only 2% can get A's. 2% of the class can get A's. And then, assuming that people get different scores, 14% gets B's in the class. That's grading on the curve. That's what it means. So it's a very competitive type of scoring. And the last thing I want to do is create a competitive environment where, I'm not going to share my notes with you, because then you're going to do better than I am.
Yeah, no, I agree. I think the other way would be better.
Exactly. So that's kind of like where I'm coming from. Because, if I start grading on the curve, then, I said, hey, winner takes all. I don't care. If you don't show up, that's your problem. I'm not going to email you my notes. I'm not going to help you. I'm not going to confirm my answers with you. Forget that. I want to get the A. A lot of law schools are like that, by the way. It's more grading on the curve, very competitive out there. That's what I've heard. Here, on the other hand, I like to be collaborative. Personally, I want everybody to get an A. That'll be like my dream. So please help me achieve my dream. Let's make. You help me to help you achieve that dream. Who wants to get an A? All right, so not everybody wants to get an A. So it's okay. But yeah, most people want to get A's, right? Because it matters. It matters if in GPA, there's a number of benefits from getting an A. And believe me, I really want you to get an A. I really do. You have to do the work. Just keep up. But this way, it doesn't allow you to collaborate. It doesn't allow me to give everybody A's using this methodology. So if you still want to decide on this one, give me your decision next week. I'll be curious to hear about it. But at least I gave you my basis for not scoring like this. Did I change anybody's mind? Okay. All right, here we go. Box plots and whiskers. Box and whisker. Okay, so this is very useful when you have skewed distributions. So this is very, you don't see this a lot, but when you have skewed distributions, it does help. Let me just jump into it. So when you get like a cumulative percentage, like this is like the 75th percentile, this is the 25th percentile, this is what we call the interquartile range. You can find the median, that's like right there in the middle. And then if you have that range, I know this is, I'll go more in detail later on. If you have the interquartile range, if you add and multiply that plus, times 1.5, that'll give you the upper limit or upper extreme. If you add that to, if you multiply this space here, is 1.5, the interquartile range, which gives you the lower extreme. I'll give you more information about this later on. I just want to give you a preview about box plots and its purpose. Like I said, it's really to identify outliers. It's beneficial to use when you have skewed distributions. So each chart and figures has its purpose, and that's just one key purpose of this one. Let me just jump to this. All right, so assignment 1 preview. Well, let me see. let's take a vote. So, want me to go over the article, or want me to give you the assignment 1 preview?
Assignment one.
I only saw. I only heard one voice.
One of the article.
Article? Wow. Well, we have a debate now. All right. Let me see what I can do. Let me try and do assignment 1 preview, and then let's see if there's time for the article review. If not, I'll be flexible with that. Let's see. Give me a moment. It's the deal outside. Jeez. Hopefully, there's not going to be a lot of traffic. I have a sense there's something going on. Let's see. Gosh, there's helicopters, there's police. A lot of stuff going on. Any intel? No intel?
No, it's just firefighters passing by.
Okay. Yes.
Someone texted that they have been evacuated from Salazar.
Oh, really?
Yeah.
Any text messages that we need to evacuate this building?
Die on campus today.
Yeah, I don't want to die today.
Yeah, I don't want to.
It wasn't on your list.
I never expected this is the way I'm gonna die. I mean, it's kind of cool.
Not
No, it's not how I wanted to die.
It wasn't on
Hey,
your
skydiving.
list today?
I'm sorry, what was that?
It wasn't on your to-do list?
No, well, exactly. It's not on my to-do list. Isn't there like a 007 movie, like No Time to Die? It's coming up. So that's kind of like me. I have no time to die. I got other things to do. I gotta give you your assignment 1 preview. So hopefully we're safe. If you hear a text message, if we get a text message, let me know. Safety's number 1 concern. All right, and then we'll do some procedures if necessary. The cool thing is we have people majoring in criminology, criminal justice, so I think we're safe. Okay, so assignment number 1. All right, so I'm going to upload the assignment number 1. So it's going to look like this. The cool thing is I'm recording this screenshot right now as we speak. So it's going to help you. You can just go along with this. So Software's data file contains about 521 10th graders from a large suburban public school. The information in the file includes the following: student ID, gender, cumulative GPA, scores on state-administered 10th grade mathematics and reading exams, scores on an 8th grade national standardized mathematics exam, and whether or not they took algebra and general math. So question number 1, test scores represented by the reading variable are on a scale ranging from 200 to 300. Generate a frequency distribution for reading. Find the cumulative percentage for each of the following scores. And then approximately 1/10 of the cases fall at or below which score. What score, roughly speaking, separates the top half from the bottom half students? So what I'm going to do, I'm going to give you a freebie, all right? I'm actually going to do this. All you need to do is you need to do it as well, and I need proof of that. So I'm just going to do question number 1, but the next ones, I'm just going to use a subset of the data, and you have to come up with the answers. Okay, is that fair? I got a few thumbs up, or 1 thumbs up. That's good enough. All right. Did you watch Cisco Neighbor by now? Back in the 80s. No. Cisco Neighbor. All right, so, okay. Look it up on YouTube and you'll see what I'm talking about. All right, so what am I going to do? Generate frequency distribution for reading. All right, so one easy way to do this is what we call a pivot table. Generate a pivot table of the data. So all you need to do is select all of your data. And that's a lot. Don't do hand calculations, all right? You'll be here forever. It's a lot of data. All right, there we go, it stops. And then go to insert, pivot table. There you go. And then you get that, you click OK. Bless you. So we want a frequency table reading. Let me double check that. Okay, so what you do is you get reading, a sum of reading, and then you drag reading here. But I don't want the sum. Let's see. So instead of the sum, I want the count. All right, so it automatically defaults with the sum, but you get the count. And there you go. Voila! Frequency table, not distribution. Frequency table. So quick, can you see? So how many students got a score of 200?
1,
Very good. How about 230?
11.
Very good. And 240? All right, so you get it. That's the frequency count. And let's see, what do I have to do next? Find the cumulative percentage for each of the following scores. So I want a cumulative frequency, cumulative percentage. It's been a while since I've done this, by the way. Hopefully I get it right. If not, I guess I'll have to grade on the curve. So let's see if I do this. Cumulative frequency. Go to value settings. Count. And I think I go to show value as. And then running total. That's the key thing. You want a running total and then click OK. Yes, I got it. Sounds surprised, right? It's been a while since I've done this. So, you know what I did, right? Well, it's going to be on YouTube, so you can see exactly what steps I took. If you have trouble, you can always email me, but essentially what I did is I dragged another reading to this values area here, and then I went to value settings. I clicked on count, and then I click on this tab, and then here I put running total in. Are we safe?
It was a gas leak.
Gas leak, oh god.
All right. If you need to back, we can. Okay. All right, I'll try to be brief. Hopefully we don't nothing happens. Gas leak another building?
Roser Hall. Oh, that's cross campus.
Oh, that explains everything. Okay. By the way, all of that's being recorded. Great. Sorry. All right. Find the cumulative percentage of that. So, okay, so to find the cumulative percentage for these scores, you have to find 226. So what is the cumulative percentage? Actually, did I say percentage? Oh, okay, so it's not the full count. So I have to put percentage. So I messed up a little bit. So let me put that. It's running total in percentage. So I messed up, so let me fix that. All right, there we go. Now it's percentage. So what's the cumulative percentage for 226? Very good, 4.99. What's the cumulative percentage for 262? Let me look down there. What do you think?
84. Then 280.
Yeah, 280. What is it?
99.4.
0.04. Yes, very good. So that's what you put for the answer. But you have to show the work. Okay, approximately 1/10 of the cases fall at or below which score? So what is 1/10? You don't know what 1/10 is, you could just easily find that out. So it's 10%. 10%. Okay, so 10%, roughly 10%, so here's 10%. Let's see, what was the question? Approximately 1/10 of the cases fall at or below which score? So which score is it? Say it with confidence.
232.
That's right. I want to hear confidence in the class. So 232, very good. Okay, what score, roughly speaking, separates the top half from the bottom half? So what should I do here? What percentage should I look if I want to get the half?
Or
Yeah,
the whole
50%, around 50%.
Yes.
248, 240. No, 247 and 240.
Okay. Well, I was looking more at 248, but okay. I mean, I'll set that. So it's not going to give you exactly 50%. Also, I mean, I was thinking like 248. So that would be that. Okay. So the next question is, determine the proportion of females in the sophomore class. So here, I'm just going to do a subset. I'm not going to give you the answer. So I'm just going to remove these. Go to gender. Oh, well. I think I gave you the answer, right? I messed up. Okay. Anyway, that's as far as I'm going. Let me do something else. Sorry about that. You're like, it's okay. Sorry. I did it again.
Professor,
Yeah.
you mean when you say show reward?
Sure. Upload the file. Upload your Excel file. So I'm just going to do a subset. All right. For the record, on the microphone, I'm just going to do a subset. So don't use these answers. I just want you to follow. I want you to learn the steps.
So, sir, so you'll give us another Excel.
It's the same Excel. It's the same Excel file.
That's
I'm sorry?
Just with different numbers?
No, you see, I'm going to show you the steps to get to the answer.
Right.
But all you need to do is, instead of selecting what I'm doing, so you select all of the numbers.
Oh, okay, I see. So you only selected a portion?
Exactly, a portion, because I'm not going to show you the answer,
Okay.
which I think I already did with the gender. But you still have to do percentages anyway. So gender, then you drag gender on values, then you get a view value field settings. Let's see. I think it's percentage or grand total. So, did you see what I did? I just put gender on the values, and then value field settings, it's count, and I identified as percentage of grand total. So the numbers are going to be different for the record, but remember to sell out, it's the same steps. All right, generate a histogram for cumulative GPA. So this is pretty straightforward, I think. All you need to do is select all of the cumulative GPA. Go to insert. Let's see where. Okay, so you click on that icon, so it'll generate a histogram. A histogram will automatically be generated. And then I ask you questions about it. Describe the distribution of scores in terms of central tendency, skewed variability, shape. Basically, just describe the shape. See if it's skewed or not, or if it's negatively skewed or positively skewed. And then assume that it's a symmetric distribution. Assume that a symmetric distribution is the cumulative GPA is indicative of the gradient on the curve. Does this distribution suggest that teachers at this school ascribe to such philosophy? Do you find any evidence to support claims of grade inflation at the school? And then the last part is generate box plots, side-by-side box plots for cumulative GPA for students enrolled in algebra in 8th grade and those who did not. Since we're a bit limited on time, I'll do this outside of class, but I'll post it on YouTube. And then all you need to do is just read the video, follow the steps. The only difference is you select all of the data, all right? But in my case, I'm just going to show you select a portion. Okay, it'll be due next week. I think it's due next week. I think there's other assignments you need to do. I'll send you an email letting you know what you need to do. Question?
What's your YouTube channel?
Oh, if you go to drolmos.com, it'll take you directly there.
It's on campus. It's the link.
Yeah, there's a link there. Yes.
Are you gonna hold the article next week?
So, yeah, we'll go over the article next week. And then there'll be opportunities. I'll give you opportunities to redo previous quizzes if you want to get a higher score. Any other questions? Or forever hold your peace. Till next week. All right, enjoy your weekend. Hey, stay safe. All right, avoid the fire trucks. See you next time.